Hello everybody, I'm back with some interesting thing that I want to talk to you today, and this is a new lecture which is going to be an extension to the configuration management we have learned about Puppet and MLN. So this is not going to be your standard walk in the park, and we're going to have a lot to do in this actual sequence of lectures. I decided to split this into a couple of sessions instead of put everything in one. So I'm gonna take my time here. I don't want to rush through all the things because there's a lot to grasp. A lot of concepts are maybe new for you, so I just want to take this slowly. And we're gonna split this into 3 parts. In the first part, we will discuss about the theoretical aspects of Ansible and automation with Ansible and Terraform. So we're gonna see what's automation and what's different from what we know so far. So I'll introduce some new concepts here. I'll try to keep this as clean as possible, not to confuse you with additional stuff, because allegedly this should be simpler than what you know so far and should work, outside the box. But it can happen that all these things can be pretty much complicated, and please, if you have any questions, just come to me and we'll discuss this in the Discord server. My name is Bruno Dzogovic. I'm a PhD fellow. My work is mostly around 5G networks and cloud computing regarding advanced networking systems. So I have a strong background in cybersecurity and adjacent cloud computing operations. So if you have anything to discuss regarding this, just please reach me out and we're gonna talk about that. So I'm available at any time. You see this is a home working condition, and that's what we get nowadays with the pandemic. And yeah, please, just if you have anything, let me know. So I will try to move myself out of the screen here because we have limited space, so you can actually see something. So I'll just remove the camera. What I wanted to mention is that before we get to the practical part, first we will introduce the concepts about why hybrid clouds and all of this, and how the infrastructure can be provisioned using automated mechanisms, and why would you do that as well. There's a lot of tools out there, and I will explain why I chose Ansible and Terraform exactly. So it's not my choice, so it's not my way, the way. I don't want you to understand that as such. So the more tools you understand and the way these things are done, I think it's going to be much easier for you to grasp some additional concepts in the future and learn some new tool. Something else I wanted to mention is that I will show you how to install this. I have put in the presentations links to the installation parts if you just get confused by any chance. But I will demonstrate this in the second part of the video. So I will put a second video about this, and the third video we will go with a fully fledged deployment and example. Okay, so I will continue now with talking a little bit about why automation. So automation is something that we confuse usually. It doesn't mean that if you automate your tasks in the data center or in the cloud, that you will necessarily have literally everything working outside the box without you doing anything. Now, let's take, for example, you have a bare metal server in a data center, 1 server, 2 servers, and you just want to make your life easier. I'm not sure that it would be very smart to spend so much time learning about concepts like this, because you don't really need to automate anything in that case. You can just be fine with a couple of scripts, and you can schedule these scripts to do more or less what you need. I've had this with a couple of friends who tried to run some game servers, and well, I wouldn't go with cloud provisioning mechanisms and artificial intelligence and buzzwords like that for this kind of purpose. So you're fine to do your things manually in that case. But in my world, where we work with 5G networks, for example, the 5G enabled clouds, they support virtual network functions which are supposed to be provisioned for the sake of network slicing in 5G. So network slicing is a logical network segmentation that should be happening on the fly, or as we call that, network slicing as a service. So it means that you're provisioning networking resources on the fly, and that can be like thousands, of servers a day, and these kind of distributed units that are used in 5G, to perform FFT calculations and all of that in 3GPP, that's called functional split. I'm not gonna get in there just to confuse you more. In general, that's a huge world of SDN networks, and everything is cloud-based. So if you're not using some sort of automation, I think you're done. You're resolved, and that's it. And it's not going to be possible to catch the end. So you have to use some sort of automation. There's no choice. The thing that we like here in this context is idempotency. So you're having stuff that are running all the time, and no matter what you do, things are going to run. You're going to have some sort of resiliency. And you want to perform, changes sometimes in the infrastructure. You want to add additional instance, additional database server or something. You don't have to tear down the entire thing to do that. You don't have to, go to the data center, plug in something, turn off the server down or whatever. That's the beauty of the whole thing. You can perform changes much easily. And that's, of course, much desirable, because you don't really want to delete everything from scratch and then change again, and that's not the way things should be done, especially in cloud-based operations. Now I want to mention that don't take this for granted, that if we do this in OpenStack and AWS, that you can't do this in Azure. I will try, I'm not promising anything now, to make some examples about Google Cloud Platform and Azure in the future for the same thing here, what we're gonna do. But I'm very busy, so I don't know if I can manage that. So far I'm just gonna show you how to provision hybrid infrastructure using OpenStack and Amazon Cloud, Amazon Web Services. Now, why Ansible and Terraform? We'll get to that part. It's because you already know about Puppet and MLN. So it's very similar, in fact, except Ansible is substantially simpler than Puppet, and it works in a bit different way, so we will see that why. And MLN is a tool developed by Kira at our university, and it's not really well maintained so far, and it works in some generic, for some generic scenarios and purposes, but that's not the only tool you can use. I just want you to show another option, like Terraform, for example. So there's other ways you can maintain your infrastructure using a code. So this concept of infrastructure as a code is something we're gonna have a very good grasp on, and this is a beautiful thing. So the hybrid infrastructure I'm mentioning, that's when you run on-premise cloud or data center. In this case we have a fully fledged cloud, and this is the OpenStack that you have your accounts in as students, and then we're gonna create a free account on AWS, and we will deploy, for example, the Elasticstack logging system. Why? For example, let's say in AWS they offer you some services like Lambda, which is serverless, or data analytics and artificial intelligence. So when you run something like that in a distributed platform like AWS, or in a third-party service provider, you don't need to hire additional team in your company to work on this, to maintain this infrastructure, and to especially to buy GPU servers and expensive things like this just for the sake to have analytics in your data center. That's very expensive. So it can happen that for your use case as a smaller company, you're much better off offloading all these tasks in AWS. And let's say you're collecting some metrics using Elasticstack or beats. You have lots of different beats. We'll get to that part in the next lectures. Beats allow you to collect metrics from the system itself, or packet beat from the network, or a lot of different stuff like this. So when you store this into a database, you can pull this in real time and perform analytics, machine learning, whatever you want. So there's a lot of options you can do. So Amazon offers you, for example, serverless models of computational stuff like this. You don't have to pay for running an instance for 200 hours. You just pay for what you use, and that's very convenient, and it's going to be much cheaper. And that's one use case why we would like to use hybrid infrastructures. Another thing is that you don't really want to clutter a lot of data in your premises. You want to keep that somewhere else, etc., etc. So this is a very popular model of cloud computing nowadays, and you will rarely find a company that's like going fully private cloud like we are at the university, because it really requires a team to work on the cloud. I was the only one working on the OpenStack, and to be honest, it's really a very difficult task. It's a multiple people thing, because cloud is a very complicated thing. So having that said, you're gonna encounter a lot of problems in this, not just about Ansible, just in general in this line of work. So I want you to attain a mindset where you go as you do stuff, and you do as you go. That's how these things work. If you come to a point where you get error or something and you just get disappointed, or you can't find a solution, you should understand that that's maybe not the only way you can do the things. Ansible doesn't work for you, great, you just use Puppet. You can use Puppet with Terraform, sure, no problem. You can use something different. It's not about the tool, it's about the way you do stuff. So if you come to the point where you realize that your assets are becoming your weaknesses, that's exactly where you're going to start failing. I'm not sure that's a very smart thing to do after all, but in general, as Aurelius said, what stands in the way becomes the way. So if the problem stands in the way, the error or whatever it is, then that's the way it should be. And you're going to resolve it, and you're going to continue, and you're going to find a way, a solution. So that's what I want you to learn and to remember. Doesn't matter what tool you use, doesn't matter which cloud platform, it can be anything, it can be any situation. That's what's important, to troubleshoot the thing, to work around the problem, not just to look it up on Google or somewhere and to find the solution because somebody else did find the same solution. That's not how we're gonna roll. Now I'm gonna start with Ansible. What is Ansible? I'm pretty sure you heard about Ansible so far, and it's developed by Red Hat, and it's an open source provisioning software or configuration management tool. So it allows you to keep infrastructure as a code, but it doesn't work in the paradigm of infrastructure as a code per se. So it's a configuration management tool, just like Puppet, except it's a bit different than Puppet, because Ansible is agentless system, whereas Puppet is agent-based. We'll see these differences later. So Ansible is OS agnostic. It runs on Linux or Windows, and you can use it in different cloud environments. So that's great. The community is growing. It used to be small a few years ago, but now it's becoming quite big. So there's a lot of support you will find online if you join mailing lists and different communities and channels. There they have I think IRC, Discord, and there's a lot of ways you can get information. You just have to go through the forums, but I think that's not going to be necessary, because for your use case, Ansible has a great documentation. It's like very good, and that's what matters, at least in my opinion. If the tool or the approach doesn't have good documentation, then that's a problem. In this case, you're set. There's everything described on the Ansible's website. So this is something I provided on the bottom of this slide. You will get these slides in Canvas, so you can download the slides. There's some interactive elements here. You can click on the links, follow the links to the sources, and there's also some videos I provided about installation, etc. So if you find my videos complicated and me boring or whatever, please visit those other videos, so I don't mind. Now, what does that mean, agentless? Like I mentioned that before. I mean, you understand the difference between agent-based and agentless systems. In agent-based systems, you have, like as the word says, agent running on the remote side, whereas Ansible doesn't need an agent because it uses SSH, so it literally establishes connection to the remote provisioned location and performs, remote execution of stuff. That's a different story. Remote execution is provisioner. We're gonna talk about it separately, so I don't want you to take that as granted. Just remember that it does remote installation of things. So Ansible is decentralized, so it's not something that you can do as you do in Puppet. Some of you asked me earlier, like what sort of system can we use? Should we use centralized or decentralized? Well, the architecture of Ansible is decentralized, but the approach of configuration management is more or less centralized, because you're the one who's issuing the management of the configuration. So it's done by admin, and we have automatically we have centralized system way of operation. So the moment your automation becomes autonomous system that can take an input from a dynamic environment, then we talk about more decentralized approach. That's very possible, and there's ways you can achieve this with the right way of thinking, but to get there it's a very rough road. So autonomous systems are not something that you can just do with one click, or to get to that one click you're gonna have to go through lots of clicks, trust me. So Ansible works in a lot of occasions. It can integrate with a lot of different systems, so not only just authentication as it's mentioned down here, but it works with other tools, provisioners, and for example it works with Kubernetes or Docker for containers. It works with as I mentioned with Puppet or Chef, another configuration management tool which is quite popular, or as I used Cobbler, for example, for bootstrapping operating systems for the OpenStack cloud. So Cobbler is forgotten thing, but regardless, still people are using that. It's amazing tool. Like I swear, I don't know why people forgot about Cobbler and they don't use it so much, but I like it very much. I'm digressing. So where do we use Ansible mostly for? So of course, if you want to do stuff, as I mentioned in the beginning, manually, then I'm not sure you're gonna need Ansible. You can still use Ansible to provision stuff on your local host and your local system, to create some sort of a playbook that you're gonna execute and install a lot of software, and you can save that for your future. So whenever you install some new operating system, instead of installing all that software manually, you just run the playbook and it just goes. Actually, I'm thinking at the moment if I can use that in my studio, because when I reinstall the Windows on my personal computer, I have so many plugins and this environment for music production that it takes me days to install the entire thing manually. So if I can use something like this to help myself, I think I should consider that. So that's a great idea, actually. So you see, you don't even have to be so close-minded. There's a lot of options and there's a lot of ways things can be done. So it doesn't matter if you maintain one server, it still can be useful. Another thing where Ansible shines is where you need to, for example, maintain servers at lower level. For example, Kubernetes doesn't do that. Kubernetes deploys clusters on top of a working infrastructure, or let's say hypervisor level 1, level 2, doesn't matter. Kubernetes works everywhere. But let's say if you want to configure the BIOS of a certain operating machine, that's not Kubernetes is not gonna do that. You can't do that. You can do it actually with Ansible for some things. There's still not a lot of options in these regards, but for example, if you want to provision Cisco router, you have some of those expensive routers, layer 3 switches or something. That's quite a thing, I must say. I've been doing that. So you can pass configurations for your switch or the router, or different SDNs, etc. So there's a lot of options you can do. Then also, as I mentioned, virtualization and containerization. You can provision hypervisors using Ansible, or you can, let's say, provision Podman or Docker or Containerd, whatever you want. There's a lot of options. That's why I like Ansible, because it's quite simple to get start with. But that doesn't mean it's gonna be simple further on when you want to go with a deep dive. So what's the difference between Ansible and Puppet? First thing is that Ansible is coded in Python, whereas Puppet is coded in Ruby. Of course, Ruby on Rails is quite a thing there, but still, being coded in Python, it's much more lightweight. For the matter of fact, Terraform is coded in Golang, so Python and Golang are, very convenient programming languages. They're very, very new, high level, and everything that you program with these languages is, quite optimized, and it's running fast and it's lightweight. Of course, don't get this for granted again. Doesn't mean that if something is lightweight, it's not complicated. Like, for example, the difference between, Einstein and Mike Tyson. Mike Tyson is heavy-weighted, Einstein is light-weighted, but we understand the difference in complexity right there, right? So that's the same here. And another thing is that Ansible works in an agentless way, whereas Puppet uses agents to perform the configuration management. Puppet, how you configure agents in order to do your job. You don't need to do this here. That's a lot of time saved, especially when you have infrastructure that's scaling. This is one of the weaknesses of Puppet. If you have a huge infrastructure and you want to use Puppet, for the 5G networks, as in my case, I'm not sure I would ever use Puppet for that. For the cloud, for OpenStack that we have at Oslo Metropolitan University, we already use Puppet for that. But for 5G, no, I'm not sure that would be smart. But Ansible is, it's very simple to install and use. You just you can kick yourself started with Ansible with just a few steps, and that's big plus. Then Ansible scales better, so it's like, as I mentioned, if you want to use something as big as 5G infrastructure, you, of course, including the cloud, the edge platforms, the Internet of Things platforms, all of that, and to manage all the Internet of Things devices, we're talking millions or something. I'm not sure you want to configure agents for that thing, and that's the last thing you want to do. Then difference is that Ansible uses YAML, Puppet uses its own DSL language. Terraform has its own language as well. It's a separate language, but still, it doesn't mean that one is better than the other. You may be used on YAML or something, but at the end, it doesn't mean that it's going to be simpler. There's everything supported in Ansible. You can use loops, conditionals, everything that you can use in a regular language. It's getting more and more complex, as the tool becomes upgraded. There's more and more things you can do. You can call modules and then plugins, and use filters to filter specific information from outputs or inputs, or etc. There's everything you can do, and this is that's what I'm saying. It doesn't mean if it's lightweight, it's gonna be simple. Another difference is Ansible doesn't check for the state of the deployment, but Puppet does, of course, because it has agents running, so agents are reporting the state. If something is missing, it's going to redeploy or do something like that. But there is no option, you're gonna have to do that. But in Ansible, there is a very valid reason why exactly the state is not being reported. You can do that through Terraform. I will show you that as well. It's actually very simple to do, but you don't really need to have state in order to create idempotency or something. There's ways how you can achieve that. Of course, Ansible created option for that. It offers you state management by using the enterprise-grade Ansible Tower offered by Red Hat. You need to pay subscription for that. It's not something wow, it's a reasonable sum, especially if you're an enterprise. So using that allows you for much better overview, and you have a guy and you have everything. So it's quite convenient. So of course they have to offer something for the enterprise level. Otherwise, if the entire tool is free, then what's the point to just create enterprise level at all? Then Puppet is a little bit older than Ansible. I mean, not a little bit, but substantially much, and that's why it has bigger community and support. So if you encounter some problem regarding Puppet, it's more likely that you will find more support than for Ansible. But that doesn't have to be the case, because depends again what you're doing. I'm not sure you're gonna go wrong if you choose either of those. So it just depends on your use case and the scenario you're deploying your infrastructure. So if you have something overly scaled, just try to make your life simpler. So this doesn't mean if you're using any of those tools, it shouldn't be like that. Whatever you're using, just of course don't try to make your life complicated in any case. Another thing I wanted to mention is about the graphic user interface. Puppet has much better graphic user interface than Ansible. Of course, you've had this experience with Foreman. Foreman is another extension that you can use for Puppet to create a very fancy graphical view about your infrastructure, and it works very well. Whereas Ansible has option for that, but doesn't really work always. At least I didn't have very good experience with that. I've heard also other people complaining, but I believe that's gonna be rectified over time. So just give it a couple of maybe months, maybe I don't know, a year or two. You're gonna have the same level as what Puppet has. Still, Puppet is older, and of course it deserves that attention and the state at which it is at the moment. So let's kickstart a little bit with the architecture of Ansible. So I think it's best if you take a look at the figure on the right side. So Ansible works with inventories and playbooks. So the playbook is what you're gonna use to write your stuff that you want to provision. But you can also keep a static inventory. Inventory is especially useful when you have replicable infrastructure. You want to do something over and over again. Let's say in your data center you have servers which are always there. You're not using something like a cloud. For clouds there is a concept of dynamic inventory, so we're gonna talk about that. Then you can call modules, plugins, extensions like that to enhance the functionality of your code. So when you pull this in YAML file in the playbook, I mean, you don't even have to write an inventory in the end. Everything that's from the inventory can be overridden through the playbooks. You can just keep the inventory, and that's what I'm gonna show you later. We're not gonna write a static inventory because we work in hybrid clouds, and let's say you want IP addresses to be used for some instance. And that's something that you don't assign in the inventory because you don't know what the IP address is going to be in the cloud. The virtual router like Neutron, OpenSwitch, and OpenStack is going to provision an IP to the instance that you don't know what it's going to be. And then you're going to have to pull that somehow and tell Ansible, okay, this is the IP address of that instance, do something with this SSH or whatever. So that's the beauty of this, flexibility, how you can do the stuff. So there is another also thing called CMDB. I'm not sure we're gonna have enough time to implement this. I'll try. If we have enough time, I'll pull it like in the third part of this lecture. So if that's convenient, so you can see how we can store information like CSV, HTML in database, and from there we can pull that and represent it as a dashboard. It's not something wow, but still, it's good to see. I'll try. First, we're gonna start with the playbooks. I'm not gonna keep this too complicated. It's not too much theory here, but I just want you to get the basic concepts. So the playbooks are literally your ways how to organize. Let's say you have a notebook and you write the stuff that you need to go and buy from the shop. This is the same thing that you want to have installed and provisioned. And this is, you can do this in a very nicely neat and organized way. You can have multiple files, divide. Let's say you want Amazon servers, we want, I don't know, Google servers, etc. So you can divide this into multiple files, or you can put everything in one file. It works. So you can assign different host groups, roles, functions inside to perform on this, tasks. And these tasks, they can take lots of arguments and details. So we'll get to that, in the practical part. So in general, that's what the playbook looks like. A playbook can contain, inside you can put modules. You can call modules. The modules, they are functional codes, let's say Python codes, which is already fixed in advance, and it's put in the Ansible Galaxy. So Ansible Galaxy, it's like the Puppet Forge, which is a repository for the modules. So you can call these modules by the Ansible-Galaxy command, and you can install these modules by yourself. Or you can also develop your own modules. If you know some Python or Ruby or some other language, that's perfect. There's a link down how to develop modules and the guide, so you can check that. And sometimes you may not find the right module for your use case, and that's where you would like to really put some effort and make something that's gonna work for you in the long run. So a module can be anything. Let's say, for example, ping, a simple ping to ping a remote machine. So this built-in module from Ansible is something that you're gonna call using FQCN, like a fully qualified name. But the thing is that Ansible in the previous releases, it could call these modules, but just writing the name of the module itself, ping, and that's it, and it works. However, nowadays it's recommended that you put the full FQCN, so like ansible.builtin.ping, and then you're gonna have the exact module loaded for that particular task you want to perform on a particular host. That's done just to avoid confusion. It's like in OpenStack when we use IDs, UUIDs, instead of names for instances or images or entities inside the cloud, because these ID numbers are gonna be always different, as names can overlap sometimes. Plugins, there's a lot of plugins you can use, like netconf plugin, for example. You have this on the side here, so I've left this clickable, so all of this is a link. You can click on the site and it will lead you to the site. You can refer to these when you work and you want to check what they do and use some of those. Let's say, for example, the second Become plugin. That one is designed specially to allow you to execute, let's say, tasks on the remote hosts as a sudo. So you can say become sudo or root, so you can execute certain tasks as a root. So there's a lot of ways this is done, and this is how you can also develop your own plugins for specific tasks. So that's the beauty of this, the pluggability and expandability of the tool. So now we are getting to the inventory. The inventory is literally something like a playbook, except the inventory is kept in a default location. So it's usually in etc Ansible hosts, but if that path doesn't exist, Ansible will look in other directories, like for example your exact playbook directory where you're executing your commands from, the working directory where you're at the moment. So in that case, if you have Ansible.cfg file, the configuration, it will be pulled from there, and you can add lists of hosts, and this is, as I mentioned before, quite useful if you want to use static hosts and you want to provision your infrastructure that you'll already know what's it gonna be. You have storage servers, those gonna be in a LAN, and you're gonna pull them through some specific VLAN, etc. So there's a it's reasonable to use something like that. But when we work with the cloud like this, you can't really know a lot of stuff, what's it gonna be. So cloud is a very changing dynamic environment. Lots of things change there, security groups and policies and IP addresses, etc. So in this case you need something like a dynamic inventory. So you can click on this link where it says dynamic inventory, you can read furthermore. So I don't want to make this too complicated for you now, and we're gonna see this through an example how it works. So in the inventory, as you can see down there are a couple of examples. So it's like your for example, chef has cookbooks. Of course, it's like it's a concept where you write your recipes and you can put them in a specific cookbook. So these recipes are literally like inventory in Ansible. What you're gonna have in your playbook this and that and this kind of software, etc. You don't really put this in the inventory. You just put the host that you want to provision and servers and names, etc. So you can name that in different ways, like alphanumeric, as it's explained in the middle. If you want to add like 50-60 servers, so in that case you're provisioning servers with specific domain names, which is awesome. That's the beauty of these things. It's very predictable. You know exactly what's gonna happen. So in Chef, for example, you write recipes and you cook that recipe. That's the same concept here. Of course, Chef works different than Ansible and Puppet. All these configuration management tools, they have their own ways how they work. As I mentioned before, I'll try this. I'm not sure we're gonna have enough time. I don't want to make the whole thing rocket science, because it can be, but I'm trying to keep this as simple as possible, but still have some realistic functional use case, not just how to install Ansible and how to provision 2 hosts and apt update on the remote hosts, and that's it. No, we're gonna install a full monitoring system, actually log collection using elk stack and beats, and feed the database from the OpenStack cloud into the Amazon cloud. So that's how we're gonna roll. And maybe if I have the time, I will introduce horizontal auto scaling of the infrastructure that you're gonna build, but I'm gonna put this in some next video as a separate video, because horizontal auto scaling is not a simple topic, but that's possible because you can collect metrics from beats, like metric beat or packet beat, and then you can tell Ansible based or Terraform based on this information, okay, our web servers are getting bombarded with requests, let's run one more VM or something. And when the requests get down, you can reduce that load. So then you're gonna have to use some service discovery in order to make the web servers work as a one, right? So you're gonna have to use like a queuing system, service discovery, etc. I'm not gonna get into that right now. I'm just saying maybe in the future I'm gonna put an example like that for you. And this is something that's very interesting, very cool. So saying about the CMDB, that I'm not sure I'm gonna make it work out of the box. If it works properly and I find some method that you can do this seamlessly. As you can see, this picture is quite old, it's from 2015. So I'll try to make this work for you, but you can have much better options for collecting information, as I said, about the elk stack and Kibana and all that. That's I think the best you can find out there. So now we're coming to Terraform. So you must be asking yourself, why do we need a second tool? Now Terraform is something that's the adjacent tool to MLM, and this is exactly what infrastructure as a code is and how it does infrastructure as a code. So it's not a configuration management tool, although you can perform certain configurations by calling provisioners, like for example cloud inits or remote exec and stuff like that. There are provisioners, but that's not the idea behind Terraform. And if you go to their website, they will tell you explicitly, we discourage usage of provisioners, except if it's absolutely necessary and there's no other way you can do certain things. So in the case of Terraform, you want to create a certain code and keep it as a configuration, and Terraform has its own language, and it's very rich. It's like a fully fledged programming language. It has its own syntax and way it does things. It's pretty much simple because it's coded in Golang, and it's very efficient and lightweight. So installing Terraform is super simple. You just download the precompiled binary and you put it in a path, and that's it. Or you can install from a package, so it doesn't really matter. In any case, it's like a ping utility. It's very simple. It's very straightforward. So there's not many commands you need to initiate to get infrastructure up and running. There's a lot of things you can do within the files and declare the ways and functions, for loops, etc. There's a lot of things, but functionality wise, it's very straightforward. You just have to initialize the Terraform, and then you can say Terraform apply, and it will get the infrastructure up and running. But before that, what you can do, you can also say Terraform plan. So when you type Terraform plan, Terraform tells you exactly what things are going to be provisioned or changed, or if something needs to be turned off, destroyed, it will remove it and rebuild it again because it's wrong or something. That's the beauty of this thing, because a lot of functionalities are replaced with just a couple of commands. So this is great, and you will see the very big similarity with MLN in this case. So now next question is, why do we need two tools? And why like adding third or fourth tool makes everything more complicated? That's not necessary like that. First thing, because you can do, let's say, a lot of these things, all of these things only with Ansible, but there's a lot of things. For example, let's say Ansible might not have a lot of things for provisioning OpenStack instances and working with the OpenStack APIs. So you're gonna have to do this yourself manually, create a lot of conditionals and loops and additional files, or call plugins and modules which are not really working for that purpose, and create some improvising way to do that. In the end you will make it work, but that's not things should work. You want to have some security and way things should be done, not overcomplicate your entire code and then fail to understand what's wrong or what you need to upgrade, and it becomes super complicated for you to follow. In that case, going with one tool makes your life much more difficult than employing another tool to do the exact job that you need from before and continue where you just need to do what Ansible does the best. Or if I can put this into a picturesque way, let's imagine this scenario. You work in a team of firemen, let's say 4, 5, 10 people, and firemen use a truck, right? So the truck has water inside, it has a pipe of some sort, and this pipe you can use to pump the water to a certain building where the building is burning, and you have a ladder, of course, you can climb, etc. So let's say you, of course, with your driving skills and your fire extinguishing skills, you're Ansible, but you need to get to that floor. You need the ladder, you need a working truck which has an engine to turn up the ladder so it can go to the 10th floor, I don't know, and you need the engine running so you can pump the water up. So even with your knowledge of knowing how to extinguish fires as a fireman, without the fuse and the water and all of this, you can just theorize and discuss how to extinguish the fire. In the end, you're gonna break up in the building manually, you're gonna climb up all the way there, and you're gonna use your fire axes, etc., and blankets, whatever you're gonna do. You can still do it, but it's much better when just use your fire truck to climb up through the ladder and just pump water directly through the window. I mean, don't get me wrong, this might be the most wrong way to do fire extinguishing. I'm not an expert in that area, but I'm just trying to give you a reference how Ansible should work with Terraform to make your life easier. So I think we established this, and we will get to the point when we do the practical part, and I will tell you exactly where things can be done in a different ways. Like you can use Ansible after you provision everything with Terraform, like in a separate way. Like you can write your playbooks in Ansible in a completely distinct way from Terraform, or you can use it as one and try to make a real orchestration. And that's exactly where I'm gonna focus and show you how to do that. So use cases where you use Terraform. As with Ansible, you can use it, of course, when you want to have some more complicated stuff, like entire application models. And this is useful when you're stacking, let's say, pools of web servers or databases, or you have clustering models, or routing meshes for networks, etc. So these kind of complicated tasks is what you want to automate and use certain chunks of code which are ready, and these are defined as resources in Terraform. We're gonna get to that point. Another example, like self-service clusters, or black box testing and demos, different software demos. So you want to provision a demo. This is a great example. For example, you want to provision a demo. You're on some conference and you want to show off your app or whatever you have, and suddenly your laptop stops working and your Vagrant or whatever you were running on your local laptop is just not there anymore, or VM. So what you're gonna do? Nothing. But if you're running something in a cloud, which you can provision on the go using Terraform, it's just gonna be there, and you can take someone else's laptop and it's like, sorry, can I use your laptop? And you can just continue, just need SSH access and that's it. So things like this. And also it's very easy to get started with this and also destroy your infrastructure. So if you have like testing environments, like staging and quality assurance environments, you can use this. Use Terraform to perform all this staging. So that's how I'm gonna show you the exact example in this case. We're not gonna just copy code from a GitHub repository, although I have this all this thing in GitHub. I did it manually, of course. I tested everything, but I'm not gonna allow you to fork this and clone the repo and just apply everything and go up and running. You're not gonna learn anything like that, but you're gonna type the code letter by letter. I don't care. That's the way things should be done, and that's the way best how you're gonna learn this. So that's exactly how it's gonna be tomorrow when you're gonna start working in a certain company. You're not gonna, of course, you're gonna copy chunks of code from somewhere. Maybe you have some of your own stuff from before, etc. But in general, you're gonna have to write a lot of your own things. Like, for example, I have loads of code and examples I'm saving from software-defined networking, and yeah, I can copy some of that, but that's for a certain use case in a scientific research environment. If I work, I don't know, in a telecom operator, most likely I'm going to use something different in any case. But that's what I want to tell you, that you're going to have to be adaptable and understand what you need to do in reality. So reality is a little bit different than school. So at school we just do stuff a little bit the easier way. But I'm not gonna try to make this again too complicated. You're gonna get most of these things out of the box. It's not very complicated. So this is exactly what we're gonna do. The last point about multi-cloud deployments and these hybrid infrastructures that are very popular nowadays. So we'll get to that eventually. Now there is a video here. It's a link to a man that explains the installation of Terraform. It's very straightforward, and this is on Linux. Terraform works on Windows as well. So if you have Windows, if you want to use Windows, I suggest that you use Linux, because we're gonna work with Ansible together. So in any case, you can use Windows to run Terraform. The CLI is gonna be the same, except the installation is going to be a bit different. So the way you're putting things in the path variable in Windows, it's a bit different than in Linux. So make sure you take that into consideration. I will also demonstrate the installation of this on Linux. I'm not going to go with Windows too much. I don't want to complicate the whole thing, but it's pretty much straightforward. Yeah, that's the video. So you can check this. It's clickable, so you will have this into the presentation when you download. In any case, there is, let's say, a simple explanation of the reference architecture of Terraform on Microsoft Azure. Of course, Microsoft Azure uses a little bit different terminology for their ways of doing deployments, like monolithic versus high availability, etc. Standalone versus active-active. So you don't have to remember these concepts. I'm not gonna ask you questions about Microsoft Azure, far from that, but just a reference to see how, it's very similar the way things are done in OpenStack or in AWS. Just the terminology is different. Of course, some details, but in general, that's that's how Terraform works. It's cloud agnostic, so it can work for you in Windows environments or even OpenStack. It doesn't matter. So if you choose, let's say, of course, depending on your operational mode, you can have like one VM, let's say, or you can have like lots of VMs, like we're gonna have in our use case. So let's see. Actually, I think I have an example here. This is a little bit about the object storage, the Azure Blob storage. So that's we're using the Ceph object storage in OpenStack. Virtual networks called VNets, and GZRS is like G-redundant storage, which is distributed storage. This is the object storage dispersed across multiple cloud regions for redundancy for different purposes, and this is synchronized. So this is more or less the same how things are done in Ceph. We're gonna come to Ceph at the end of this course, so we're gonna put some special attention to that, and I will show you what kind of problem we have with Ceph with this current release of OpenStack, and that's why some of your VMs are not being provisioned correctly and they get error state, which is fixable. You just have to reset it or something, but in general it's about the queue that storage gets to assign specific pools for OSDs in Ceph, and there is not enough provisioned or over provisioned, and it's just gonna skip. So in an instance when you're running 10 different VMs, maybe 2 just gonna skip the active state and they're gonna end up in an error state. Doesn't mean that they are really in an error state. It's the storage that says, okay, we don't have enough pools for this particular object, and in this region of the cloud, when you're putting this, we have only one region for the matter of fact, but that's how Ceph works. So the crash algorithm, if it doesn't have some scaling, like auto scaling of these pools, it's gonna have impact on the cloud when it's getting overly used and used over time, and this is something that you're gonna have to do manually to release it, to adjust it, to calculate how much pools you're gonna have, and to adjust the number of pools accordingly. Otherwise you're gonna have some issues like this. But I will also show you how to use Terraform to bypass these issues of error states and achieve an active state, or run the entire thing until active state is not achieved. There's gonna be example for that. So shortly, the infrastructure diagram, just like we're gonna do, you're gonna have an application load balancer or a bastion host, and like in the same subnet or in a different subnet, in the same virtual net in a different region. That's how Azure segregates its resources in subnets, VNets, and regions. It's more or less the same like things are done in OpenStack, but this is just an a reference for you to see that if somebody mentions Microsoft Azure, don't panic. It's you already know more about it than you think you do. This is another option, like high availability, and it's like called active state. You see what's the difference here. You have just the database in that region and blob storage, the actual object storage entity, and here you have caching using Redis or something else. I don't know, you can use caching with different software. So in general the cache is put in a different subnet. So yeah, there's lots of ways you can do this. In general, Terraform works with all these things, so that's the point you need to remember for now. So how does Terraform do the job? So Terraform creates .tf files. I mean, you can use one TF files for everything. You can crank up the entire code in one TF file. But then I'm not sure that's going to be very smart, because you're going to get very confused, especially if you have big deployment. You're going to have to put your providers there, like especially if you have multi-cloud deployments like OpenStack or VMware, like in this case on the right you can see in the icons, or I don't know, you can use Azure, and then you put like all the variables for your deployment, including your instances that you want to deploy, and then you just run everything from one file. Yeah, I don't think that's gonna be very smart, and I will tell you why when we have the example. because it's going to become very confusing. That's why we're going to divide this into a couple of different files. Like providers, we put in a providers files. Instances that we want to run, we put in instances files. Or you can even divide it, instances -OS, or instances -AWS, instances -VMware, etc. .tf. So you can divide these things, and Terraform considers all these files as one. Still, if they're put in the same directory, they're considered like a single file, and they're gonna run regardless. So after you do that, Terraform will generate a file called tfstate. So tfstate is like a JSON file where you have, you know, all the information that the OpenStack, in this case, or AWS, pushes towards Terraform, and tells Terraform, okay, you're giving me these instructions to run these things, and here is what it's gonna be. IP address of this instance, here, this is the name of that instance, the ID, all these things. So imagine, you know, the full information that you have for your cloud infrastructure put in a single file, and that's Terraform.state file. So in this state file gets updated each time you want to, you know, deprovision or run the infrastructure again. So if you make some small change, Terraform will push that state file tfstate into you know, backup. So it's going to be terraform.tfstate.backup, and it will create a new tfstate file, you know, with the actual updated state of your infrastructure. And that's where Ansible is going to get the state from, okay? Because Ansible doesn't keep this state unless you don't use Ansible Tower, and you don't really need to use Ansible Tower in this case. So Ansible will get the state from Terraform. That's the whole thing. This is what I mentioned. I can suggest that you watch the video that I put in this slide. This is exactly from the company that develops Terraform, and they will explain you the best about the architecture and more details on Terraform. So I think that's a very smart thing to do, and it's going to be much easier for you to understand when we get to the practical part. And these videos are not big, so these videos are just, you know, just enough for you to grasp the concepts behind the tool. So there's a couple of things we're gonna have to understand how you're gonna have to use Ansible in order to make the best use of Terraform for your use case in this case. You do this by defining the providers first in Terraform and all the necessary things you want to deploy. So let's say you want OpenStack provider, AWS provider, instances that you want to deploy in the cloud, then you know, IP addresses, floating IPs, security groups, subnets, etc. If there is something like that. I'm not gonna go into such a big detail to, you know, give you a nightmare of an example, but I'll try to keep this as simple as possible. But then again, we're gonna have to use Ansible to install the necessary stuff after this is done. So in fact, Terraform first does its stuff, and then Ansible, you know, provisions the whole thing. But the only thing that you're doing here is you're using Ansible to do the whole thing. So you use the Ansible playbook, you run the playbook, and the playbook runs Terraform and does the whole thing. And then Terraform reports back to Ansible in variables that you're gonna have this and this IP address, and this is put, you know, in a output, so it's pulled from the output into a registered variable in Ansible, and from there, you know, you're using this state to continue doing your job, to SSH to that particular instance that you got and continue your work. So this is, you know, the dynamicity of that inventory. That's why we don't specify hosts in the inventory, because we don't know which hosts they're gonna be. And, you know, putting this into files, I'm not sure that's a good idea, especially by using Linux shell. So I wouldn't try that. So there's ways and plugins and, you know, modules how this works the best, and this is something I'm gonna explain. That's the video, so let's keep this. It's by HashiCorp. The way Amazon integrates with OpenStack is through EC2 API. There's you know, certificates and keys that are used for the communication between OpenStack and Amazon. So this is how the entire transfer of logs between the Elastic Stack and the actual OpenStack infrastructure it's gonna happen. Last but not least, I mentioned it's possible to horizontally scale due to cloud bursting, and based on the metrics you can pull through Elastic Stack, this is something that you can do in any cloud or in any environment. You just have to think that way, this autonomous way of thinking. So I will show you this in practice. This is just a small detail, nothing fancy. And first I'm gonna have to ask you to have some things prepared in advance before we get to this part. I will go through this in the next video, and we're gonna explain in the second part what you need to do, what to install, a couple of things, and to prepare before we get to the third part of the video. So first, make sure you have access to the OpenStack project and your student user account. If you don't have that, please reach out to me or to somebody of us, and we're gonna fix this for you. Second, you should create an account on Amazon Web Services. It's free. There is a link. You can click on the link here and you can proceed. And I'll get to that in the next slide. The next thing you need to do is to have SSH access. So guys, please, like I've heard this before a couple of times and experienced with some of you. There's always some issue with generating SSH keys and using SSH keys, etc. Just please make this work and grasp the concept of OpenSSH, because it's very important for you. It's going to be used everywhere, and it's something that you need to know out of the box. So if there is something unclear regarding SSH, please do not hesitate to ask me questions, because I don't know if you know it or not. If you don't ask the questions, I assume you do, and then we're gonna have a problem if you don't. So this is the basic things that you need to go through before we can proceed with some other things further. Then installation of Terraform and Ansible, we'll go through that, but you can do it yourself. It's nothing wow. I will suggest that you use virtual environments for this. I will put a file for this whole video sequence, and I will add these steps within this file, so you can do this by yourself in a always repeatable way. But I will stress the usage of virtual environments, because sometimes you need to spend time troubleshooting your Linux distribution because your Python doesn't work, it's a different version than the pip3 or this and that. There's a lot of ways this can go wrong. So making sure that you run Ansible from a virtual environment is a great way to skip a lot of these things. You can use Vagrant if you like it. I don't have anything against it. It runs a VM, and it's a very popular tool for running virtual environments. But I will explain this with Python virtual environment, because it's very simple. You just create a directory, you put your virtual environment there, and that's it. You don't need to make anything fancy for that. You just need to skip problems with Python versions, links to the correct Python version, which version Ansible is going to use, etc. So don't try to mingle with this to uninstall Python 2, install Python 3. You're gonna mess up something, and you're gonna spend more time troubleshooting your Python on your Linux, which I did a couple of times, and it's not nice. It's not a nice experience. Just don't do that. Run everything from a virtual environment, and you'll be set. Another thing is that you're gonna have to have a REST API access to OpenStack and AWS. So the REST API access is restricted at the Oslo Metropolitan University from outside of the Oslo Met network. So for that purpose, there's two ways you can do this. First way is to run an instance in the cloud, like manually, and use this instance as your master instance, as your a control node, as we say that in Ansible terminology. So this control node is from where you're gonna issue your Ansible commands, as well as you will have the Terraform installed, or your virtual environments, all these things we talk about. So you're not gonna use your laptop, you're gonna use a VM and take it from there. So you can issue API calls directly from OpenStack to OpenStack, or there is the option to use the Oslo Met VPN. There is a student VPN you can use. I have my own VPN running in my 5G network in my office, so I can use that network slicing entity that I'm always connecting through my Windows, and I have a better connection through that. In any case, you can use the Oslo Met's VPN. I will provide a link for this into the document, the handouts that you're gonna have in Canvas. So that's the most important things. And the other thing is, like, guys, please back up your stuff, like scripts or YAML files, Terraform TF files, whatever you have there, whatever you're gonna write. Just, you never know what's gonna happen. Remember to back up. Even create a cron job or something with rsync, or I don't know, just do something. Put a USB drive if you're doing on your local laptop, or just do something about this, because in the end, yeah, we have the codes, we have everything, but there's stuff that maybe I don't have, and it's not put in a repository, or it's not there. It's something you did. So if you lose it, I'm sorry, but I won't be able to help you. That happened many times to many colleagues of mine, and they come for help for the cloud, and then I say, like, I can't promise anything because I don't know what you did, what happened, what's the scenario, and I don't know. There's stuff you can return, you can rescue, but in many cases, we're not gods, and we can't do literally everything. So just please back up everything you need, even every 5 minutes, every 10 minutes, as much as you can, as much as you have changes in your files. That's very important. Last but not least, some words about the Amazon Cloud free tier account. So when you create a free tier account, you have you're actually using until you overuse, and then you need to pay. So what you need to provide to Amazon is your debit card or credit card, whatever, but they do this for two reasons. First, to have you as a customer. Second, to identify you as a real person, that you're not just gonna create an account there and get lost, or just mess up their registry with unused accounts. So they want to know that you're gonna be responsible about your account, that you know what you're running there, and things like this. So don't worry about that. It's fine. That's refundable. Everything's okay. So no worries about this. Then you're gonna have approximately or exactly 750 hours of running small instances for 1 year. That's pretty much enough, because we're not gonna leave this running. We're just gonna show the example, and you're gonna test and see how it works, and we're gonna just tear down the entire thing, and then you can close your account, etc. So don't worry about that. In any case, there's a lot of information about this, and I provided the links in the presentation, so you can just check all of this, how it works. Amazon has this explained in details, but in general you will be fine, because we're not running any specific workloads there. You can install services like serverless, let's say Elastic Stack and all of this. It's out of the box. It's like a way for one click. It's already pre-installed on Amazon. You just have to instantiate it, and that's it. But we're not doing this. We're going more our way, more manual, direct approach. We don't want to wage the war using ballistic missiles, but we're going with swords, so that's the best way to learn about courage, not riding the chair and controlling a drone, but using a sword and a bow. So this is something you don't have to worry about. And of course, if you have any questions about this, just hit me up. I will pass these slides for you, and we'll skip to the next video. So thank you for your attention, and see you next time.